My name is Brenda Roundtree, and I am presenting on changes in the brain with Alzheimer's disease. This is my pathophysiology presentation. Alzheimer's disease is the leading cause of age-related dementia in the elderly. It's characterized by slow yet progressive declines in cognitive and social functioning, and this also includes memory loss along with changes in personality behaviors. Now, over 5 million Americans suffer from Alzheimer's, and there are millions more affected at the global scale. Age of onset can usually occur between 40 and 90 years old. However, it does more commonly occur after the age of 65. Women remain at higher risk for developing Alzheimer's than men. The severity of the symptoms really depend on the changes that occur in the brain as the disease progresses. At this time, unfortunately, there is no cure that exists for Alzheimer's. There are current treatments that are available, but they only relieve symptoms or delay progression into the more severe stages. Unfortunately, too, Alzheimer's does inevitably lead to death. A healthy brain, it really does comprise billions of neurons. They're designed for transmitting and processing information as electrical and chemical signals as they move across a very complex but microscopic neuroelectrical system. When Alzheimer's develops, it really does upset the delicate balance that exists between neurons and maintaining optimal functioning because it's capable of destroying memory and cognitive skills as we age. Researchers believe several characteristics can contribute to the overall risk for developing Alzheimer's, and these include genetic, lifestyle, and environmental factors. And these factors play important roles in Alzheimer's progression, and they can vary by individual, and it can lead to inflammation, free radical production, disruptions in energy production, and even cause atrophy in certain areas of the brain. Symptoms usually do not manifest until years after significant changes have occurred in the brain, and sometimes decades later. Alzheimer's first targets the entorhinal cortex and the hippocampus, and these are the regions that are responsible for memory. It also alters regions of the cerebral cortex, and these are areas that really do impact people's abilities in language, reasoning, and social behavior. As Alzheimer's progresses, it affects other areas of the brain until an individual eventually loses all function. And unfortunately, it does ultimately lead to cell destruction and later on death. As people age, the brain shrinks in size to some degree, but with Alzheimer's, the structural and functional changes that occur cause further degeneration and deterioration. These changes can lead to the destruction of neurons, which eventually cause symptoms to develop. Symptoms that are often seen in Alzheimer's, they include impaired memory, judgment, and reasoning. People also experience feelings of restlessness and at times issues with interpreting visual information. Unfortunately, symptoms go unnoticed because they mimic those seen in normal aging and don't usually interfere with daily living activities. But symptoms eventually do become more evident as individuals progress through the stages of Alzheimer's, especially to those more affected. Now, in normal cellular processes, neurons communicate with one another. As they do, they release neurotransmitters that can travel to nearby neurons across synaptic gaps. These chemical messengers, they bind to dendritic receptor sites, which enable communication within the brain. Although it is unclear as to whether neuronal changes in the brain take place because of AD or simply exist as its underlying mechanism. Recent evidence indicates specific changes take place at the cellular level, and this disrupts normal cellular processes. Now, amyloid beta deposits and neurofibrillary tangles form when alterations occur in specific proteins of the neuron cell membrane. Specific enzymes called alpha secretase and gamma secretase are the enzymes responsible for clipping amyloid precursor protein, or APP, in different areas on the cellular membrane. These actions release fragments thought as beneficial for neurons. However, researchers believe another enzyme known as beta secretase cuts APP rather than alpha secretase. When in Alzheimer's disease. The resulting fragment, along with the cut made by gamma secretase, releases short fragments of the amyloid precursor protein, and this is known as beta amyloids or oligomers. We also see them as beta amyloid plaques. These components can be predisposed to clumping. They become increasingly toxic because they interfere with the normal neuronal functioning. As oligomers cluster together, they increase in size, becoming insoluble beta amyloid plaques. Now, neurofibrillary tangles, they're another physiological hallmark seen in Alzheimer's. They develop when a specific type of protein called tau changes in such a way that it disrupts the vital neuronal transport system. Now, in a healthy brain, tau provides stability and structure as it carries nutrients and other key substances on the microtubules to all parts of the neuron. Yet, tau becomes altered in Alzheimer's, and that causes them to fall apart. The resulting strands form tangles within the neuron, and these cause neurons to detach from one another, and it eventually destroys the cell. Current evidence also indicates that glial cells play a larger role in Alzheimer's development, as well as chronic inflammation. Glial cells such as microglia and astrocytes, they're the most abundant cells in the brain. In a healthy brain, they work collectively in carrying out protective functions that often trigger an immune response. It engulfs and destroys debris such as waste, toxins, and, of course, amyloid beta plaques. As Alzheimer's progresses, these glial cells become ineffective in performing their phagocytic functions that would normally clear out the cellular debris and waste around the neuron. Rather than carrying out the protective functions, the glial cells build up near the neurons with the debris, and it releases inflammatory mediators. And I'm sure you all remember from earlier in our trimester, we learned a lot about cytokines and chemokines. But normally this is a healing process, but when you have prolonged exposure to these chemicals, it activates beta secretase, and this causes an overproduction of the amyloid beta plaques. Its toxic effects leads to alterations in the cerebral spinal fluids, and that eventually damages the brain cells. Researchers, they really are looking for more information and really trying to understand the complexities and the strong connections between inflammation and Alzheimer's, so that they might find a treatment that prevents its onset and progression and hopefully one day cure it. Now, as insoluble plaques and neurofibrillary tangles continually spread throughout the brain, tissues shrink, memory loss, and greater confusion continue for those affected, especially as they progress to more moderate stages. Now, as individuals progress to the later stages of Alzheimer's, they experience loss of communication, any form of independence and movement. They become solely dependent on others for care as biological and physiological dysfunction continues. Unfortunately, death is imminent. Now, more than 5 million individuals in the U.S. are affected by Alzheimer's, and with millions more on a global scale, as we've learned about Alzheimer's over the course of this trimester. Many fear this irreversible condition may lead to dementia as an unavoidable part of the aging process. Though researchers know so little about it, after decades of research, they now understand certain lifestyle factors can tip the scales in preventing its onset, regardless of an individual's genetic predisposition. Additionally, individuals may now fully recognize these toxic alterations in the brain truly begin years prior to any noticeable changes in memory, cognition, or behaviors. This knowledge alone can provide individuals with the necessary motivation and commitment for integrating healthful lifestyle modifications earlier in life so they can experience a higher quality of life overall in the later stages of aging. I just want to thank you for listening to my presentation on Alzheimer's. I really did learn quite a bit about Alzheimer's and how much it can really impact all of us, regardless of who we are.